Hi everyone, welcome to video 8 of two-way Anova. In video 7, we took the means from the SPSS output here from the means table and then transposed them into a more digestible, easily understandable, hopefully, table that looked a lot more similar to the tables that we're doing for the hypothetical results. Right. So next steps here, we're going to actually get into the ANOVA table, right? And so just like with the hypothetical results, we're going to take a look at the main effects first, right? And so marginal means assess main effects. And so we're going to look at the main effect of gender and then the main effect of political orientation. So we're going to see if there is a significant difference overall averaging across political orientation. Is there a significant difference between men and women? And then is there a significant difference, between liberals and conservatives? All right. Now for the hypothetical results, we just assumed any difference was a significant difference. But here we're working with real data, so we have to take a look at our p-values to assess whether we do have a significant main effect of gender and a significant main effect of political orientation. Bless you. That's my spouse hit me sneezing, so I'm sure you have your distractions at home too. All right. So let's take a look at the ANOVA table here. All right, so here is where we're going to find out if we have significant main effects of gender, a significant main effect of political orientation, and we'll also find out from this table whether we have a significant interaction. All right, but as you can see, this table is a lot busier. It seems a lot more complex. There's a lot more there's a lot more numbers here than the table, the ANOVA table for a one-way ANOVA, right? Because we have two main effects and an interaction term that we'd be looking at in this table. So let's cover up what we don't need to look at. Let's cover up the shit that we don't need to look at, and that's the first two rows and the last two rows. You can just cross those out. Don't need to look at any numbers from those. All right. And so we're left with four rows here. We have a row for the main effect of gender. I shouldn't really change this in the output from sex to gender, but I would have to rerun the analysis, and I just didn't do that for you. But so we have our main effect of gender / sex, and then we have our main effect of political orientation. We have a row for the interaction term, and then we have our error row. And so if I didn't make this clear earlier, we're not going to be writing up the results for two-way ANOVA in a MATLAB style write-up, just because we really don't have the time to do that. And really, if you can successfully write up a one-way ANOVA, you should be able to write up a two-way ANOVA. So really here, our focus is just for you to be able to look at the output and understand, sort of tell me, what's going on, right? So let's first look at the main effect of gender / sex here, right? So if we were writing this up, we would pull 5 numbers from the ANOVA table, just like we did from the one-way ANOVA, where we have the degrees of freedom between, degrees of freedom within, F value, sig value, partial eta squared value. I just want to focus in on the p value and partial eta squared value here, right? So our sig value for the main effect of gender / sex here is p equals 0.02. Right, so do we have a significant main effect of gender here? Our p-value is 0.02, which is less than or equal to our threshold of 0.05. So we do have a significant main effect of gender. And we can interpret the partial eta squared just as we did for the one-way ANOVA. So we can turn this into a percentage and say that gender is explaining 6.9% of the variability or differences in IMCP, intrinsic motivation to control prejudice. And so I believe that's a medium effect. And so if it's helpful, you can write right next to the marginal means for men and women here, that we do have a significant main effect of gender, p-value 0.02, partial eta squared 0.069. Right? So we have a significant main effect, so we know that these marginal means are significantly different, that women are reporting significantly higher levels of INCP compared to men. Women are reporting that it's more personally important to them to control the expression of their prejudices compared to men. That's something that we didn't know before. Okay. So let's look at the main effect, the marginal means for main effect of political orientation, the marginal means for liberals and conservatives. And so, we already did the between subjects, the one way between subjects Anova, and we already know that we should see a significant difference here, right? So if we look at the Anova table and we focus on the p-value and partial eta squared value here. So we have the main effect of political orientation. We have the sig value here. You see that we get the triple zeros, so we denote that as p less than 0.001. So we do have a significant main effect of political orientation, and we have a partial eta squared value of 0.228. So it's quite a large partial eta squared value. So political orientation here is explaining 22.8% of the differences, right, in IMCP. That's pretty big, right? So we know now that we have a significant main effect of political orientation. We know here that the marginal means are significantly different, that liberals are reporting significantly more higher levels of IMCP compared to conservatives. Now, I forget if I've done this before, but again, we do not have moderates here, just because it would just make the output considerably more complicated. So we're just including liberals and conservatives here. We could easily do a two-way ANOVA here where we could include moderates, but again, the SPSS output just gets way too complex. So we're just looking at the differences between liberals and conservatives here. So we have a significant main effect of gender, significant main effect of political orientation. Now we turn to the question of whether, the gender difference that we're finding between men and women, is this gender difference going to replicate for both liberals and conservatives? So is the simple effect of gender going to be significant for liberals? Is the simple effect of gender going to be significant for conservatives? And we're just as interested to see whether the difference between liberals and conservatives here, this effect of political orientation, is that simple effect of political orientation going to be significant for men as well as women? So we're going to find differences between liberals and conservatives for both men and women. So is there going to be an interaction between political orientation and gender? And so we can go back to the ANOVA table and then finally look at the sig value, the p-value for the interaction term here. And so you see sex, and then you have a little asterisk, and then political orientation, the variable name here. So an asterisk sometimes stands for multiplication. So this is sort of like sex multiplied by political orientation. So this is, it's symbolizing the interaction, the sex by political orientation. And we see that for this interaction term, our sig value is 0.031. And so our sig value here is significant. So we do have, a significant interaction. Right? So that means the effective political orientation is going to be different for men versus women, and or the simple effect of gender is going to be different for liberals versus conservatives. And so we'll take a closer look at the simple effects here in a second. Before we move on, I just want to address one more thing in the table here, and that's the R squared value. So you notice a big R squared equals 0.318. And so R squared here represents the total contribution of all independent variables in predicting the DV. So partial eta squared represents how well an individual independent variable and an individual IV predicts the DV. All right. R squared here represents the total contribution of all the independent variables in the ANOVA in predicting the dV. So it's almost like we're adding up the partial eta squared values, but if you add up the partial eta squared values, they wouldn't total up exactly to the R squared value, and I just don't have time to get into the reasoning behind that. But it's sort of like if we're adding up the partial eta squared values here, we get something close to the R squared. All right. And so we can turn this R squared value into a percentage, just like partial eta squared. So we can say that all the independent variables in the ANOVA explain a total of 31.8% of the variability or differences in our outcome, in this case, IMCP. Right. So partial eta squared represents the contribution of one independent variable. R squared represents the contribution of all the independent variables in the ANOVA. And so R squared will see this big R squared come up again once we get into correlation regression. So it's a good time to point it out here and get used to seeing it. So we can answer the questions 1 through 5 here. So is there a significant main effect of political orientation? Yes. Which group scored significantly higher? That would be liberals. Is there a significant main effect of gender? Yes. Which group scored significantly higher in this case? Women, right? So overall, liberals, right, and women expressed greater concern. It was more important to them to control the expression of their prejudices, right? But, right, there's going to be big but. A big but or two big buts, we're not sure. There is because there's a significant interaction, there are going to be some big buts coming up. Either one big but or two big but, we'll see. Right. And so we're going to see different answers for 6 and 7 and or 8 or 9. So we should get a yes, no, no, yes pattern for at least 6 or 7 and or 8 or 9 to find out where the source of this interaction is. Right. I thought, yeah, sorry. I wanted to end the video here. And so we can also confirm that there's an interaction by plotting the cell means in a line graph, which is something that we haven't done yet. I wanted to take a look at the Anova table first and show that there was a significant interaction. And then if we plot the cell means here for women and men, we can see that the lines here for men and women, that the slopes are not very parallel, right? Which again confirms that we have an interaction here, right? That the slopes for men and women, they do not look like railroad tracks here. They are not very parallel. So again, we do have an interaction going on. So in the next video, we'll take a look at the simple effects output from SPSS.